All right, so how does this all apply to actually flying an airplane?
Well, so taking all that we've learned so far, putting it together, um, we can conclude that as the pilot of a fixed wing aircraft of today, you have one job and one job only, right? That one job is that if you imagine this to be an arrow of, remember how we said you imagine you're sitting as a pilot in a stationary airplane and the wind is rushing past you?
Mm-hmm.
Imagine this to be the arrow of the wind with all of these parcels of air rushing past you. That is the relative wind. It can come from below or it can come from straight ahead. It can come from the left or from the right. It can be weak and far away, or it can be strong and right in your face. That relative wind is your number one priority. Getting it pointing in the right direction and blowing at the appropriate strength is the one thing you need to do in order to control your airplane. Because that's going to determine the wind that blows over your wings, which gives you lift. Therefore, the one thing you need as a pilot is to be aware of it and hopefully to have some sort of instrument that tells you about it. And why do you need an instrument? That is, a lot of people ask this question, right? So why do I need tools inside of my airplane to help me visualize or understand the relative wind? Well,
Is there currently a tool that or an instrument that helps people see that?
there are tools that, in a scattered way, give you aspects of the relative wind, but no single one that gives you everything in one single place. And looking at one of these things, you are likely to forget the other. And being required to scan several of them, you are likely to forget them entirely. And so the thing about the important question, though, is a lot of people say, I don't need an instrument. Well, but you can't actually see the wind, right? I mean, if you imagine, let's say, water skiing. The process of water skiing over the surface of the water, or surfing with a surfboard across the surface of the water, is very similar. In fact, it's almost identical to the process of skimming the air with a wing. And yet you can see which direction you're going relative to the water because you can see the surface. It's right there. What you cannot see is the air rushing past you in an airplane. And a lot of people, after thousands and thousands of hours of flight, have indeed come up with heuristics. Well, I know how it feels when I'm slow. I know how it feels when I'm fast. I know how it feels when I'm pushed over to the left. In other words, yawed, right? But to acquire this feeling is really, really a long effort. And I think we are failing our pilots if we don't take seriously the need to have something to get them bootstrapped and sort of have almost like a helper by their side telling them how things are going and kind of a source of truth that they can check their intuition against.
Mm-hmm.
So the visualization I like to use is basically an airplane with a big arrow pointing at the pilot. And the idea is here that we're measuring three things, right? So first of all is the angle of yaw, whether the wind is coming from the left or the right. And normally you might think, why would you ever want the wind to come from the left or the right? Well, it turns out sometimes when you're landing in a crosswind and you have to kind of fly sideways a little bit, you actually end up in a position where you're flying the airplane sideways and landing, right? Sometimes you want to fly the airplane sideways in order to use the fuselage as an air brake. Let's say you want to descend really quickly. So these are all techniques. It's part of your job as a pilot to control that. The second thing is the strength of the wind. If it's a very weak wind, you're going very slowly, you need to be aware of that, and you need to be aware of the behavior of your plane versus a strong wind when you're going very fast. But most importantly is the third one, which is the so-called angle of attack. This is the angle that your wing makes with the onrushing flow, and this is what determines the amount of circulation that your wing is creating. In general, when you're flying slower, you're going to have a weak wind, you're going to be at a high angle of attack, and you're going to be sort of mushing into the air. Now, if you're descending while you're doing that, then your airplane is going to be more or less horizontal, but you're still going downwards, and the angle it makes between the onrushing wind and your wing is still going to be pretty high. In any case, regardless of how you're pitched relative to the horizon, the important thing is how you are pitched relative to the relative wind. This arrow right here, right? And why is this an issue? Well, so it turns out at a high enough angle of attack, when your airplane is really mushing into the air will refuse to turn the curve around the top of your wing.
Because it will just crash into the bottom?
It will bump into the bottom, but over the top, it will start flying off the wing. Mm-hmm. And it will produce less lift than it did before. So here you are, you're at a high angle of attack, and then the wind starts coming off of the top of the wing. Now you start dropping, which means that now your wind is coming from below even more, which makes the situation worse, which means you drop more and more of this. Eventually the tail of the airplane pushes you nose down, and eventually you pick up speed and stabilize, or at least you hope you do. This is called a stall. And an aerodynamic stall in this fashion is interesting and fun to do when you're really high up. When you're about to land and you're 300 feet off the ground, it can be fatal. So that's the first thing. The second thing is, if I were to stall my airplane while my wind is sideways, when I'm yawed relative to the wind, one of the wings is going to stall before the other. And what that means is, it's typically going to be the leading wing, because that has a higher angle of attack because of various aspects of how it stabilizes itself, the so-called dihedral, which is this little angle up at the top. And that wing will drop precipitously. In fact, the airplane will almost go inverted as it rotates around and enters a spin. And it turns out that airplanes have two stable flight paths, one of which is flying straight ahead, and the other is spinning like a top.
Uh-oh. And that's why you don't want to spin.
Right, exactly. Sorry, let me duct tape my wing on so I can continue the demonstrations. All right. And spins are even harder to recover from than stalls. And if they happen at low altitude, they can really be a killer. And what we have seen is people have some relatively benign thing happen in their airplane. Let's say their engine quits. In general, your engine quitting should not be a horrible problem, because now you just glide, find a place to land, and land. Or at least in most cases, it should be quite survivable. But a lot of times people panic. They start pulling up on the stick, thinking that this will make them go higher.
Or slower?
Well, it will make them go slower, but by pulling up on the stick, they feel like they're avoiding the ground. Mm-hmm. It makes them go slower. Remember, we increase the drag, mm-hmm. and it also gets them closer and closer to stall. Mm-hmm. Eventually, they stall, and if they're not paying attention, they're also yawed, and the result is a spin. And so a stall spin following a power failure is an unfortunate and very common way that we are losing good pilots and good airplanes. And so the question is, can we actually improve on this record? And we hope that our way is to educate people and get them to understand the intuition behind the relative wind, so that the correct thing becomes natural. So that when you feel like you're getting too close to the ground, your first instinct is to realize you actually need to pitch down to get your best glide speed. And you have to pitch down at the ground rather than pulling away from it in order to glide further. This is so counterintuitive. And yet, how can we get someone to actually internalize that in a panic situation? There's no panacea. I don't know of any single magic bullet, but I do know that in teaching people more about the relative wind and getting them to have more of an intuition about it has got to be part of the answer. And so the solution that I have come up with is an instrument that puts all the information about the relative wind into a really easy, simple, easy to understand format. And it is in two parts. The first part is that we must measure the relative wind properly, and the second is that we must display it in an easy way. So let's talk about the display first
In our next chapter.
in our next chapter.